Hey guys, how's it going? Mr. Mitchell here. In this video we're going to go over 4 worked examples to show you how to do problems involving composite particles. Now if you haven't already done so, check out my previous video covering the theory on this topic, as that way you'll be able to apply what you learned in that video to this one. So let's get going. Question 1 says hadrons are composite particles. An example is the proton. Part A says what is meant by a composite particle. Well, remember from the theory video that a composite particle is a particle that consists of other particles, and that remembers the opposite to a fundamental particle that is not made up of any other particles. Part B says to sketch a diagram to show the quark structure in a proton. Well, if you were to sketch the quarks inside a proton, it would look something like this, where you've got 2 up quarks and 1 down quark, and they're joined together by gluons. And lastly, part C says to show that the charge on a proton is plus 1e. Well, remember to find the overall charge, we just need to add up all the charges of the individual quarks. So you should remember that the charge on an up quark is plus 2/3 e, and the charge on a down quark is minus 1/3 e. So remember we've got 2 up quarks and 1 down quark, so that means we can add 2 of these charges plus 1 of these charges. So we have plus 2/3 e, plus 2/3 e, minus 1/3 e, and if we sum that up we get plus 3/3e, which is the same as plus 1e. So that's us showing that that is the total charge on a proton. And part D says, is the proton a baryon or meson? Explain your answer. Well, remember a proton is going to be a baryon, and that's because it is composed of 3 quarks. Question 2 says a neutron is another type of hadron. Part A says to sketch a diagram to show the quark structure in a neutron this time. So remember a neutron has only 1 up quark but 2 down quarks, and again these are joined together by gluons. Part B says to show that the charge on a neutron is 0. So again we just need to take the charge of the individual quarks here and add them up. So we already know the charge on an up quark is plus 2/3 e, the charge on a down quark is minus 1/3 e, and we have 1 up quark and 2 down quarks. So we're taking one of these and adding it to 2 of these. So we have plus 2/3 e minus 1/3 e minus 1/3 e will simplify to 0. Lastly, part C says, is the neutron a baryon or meson? Explain your answer. Well, remember a neutron is a baryon because it's composed of 3 quarks. Question 3 says a particle called the sigma plus has a charge of plus 1e. It contains 2 different types of quark. It has 2 up quarks each having a charge of plus 2/3 e and 1 strange quark. What is the charge on the strange quark? Well, here we know the overall charge this time, and we're just trying to find the charge on one of the individual quarks. So we're saying the sigma plus particle is made up of 2 up quarks and a strange quark. So to get the overall charge on the sigma plus, we would need to add up the charges of the 2 up quarks plus the strange quark. So to find the charge, we can say that we have plus 2/3 e plus 2/3 e from the 2 up quarks plus x, where x is the charge on the strange quark that we're trying to find, and this is equal to plus 1e, because we were told that was the total charge in the question. And then we just want to find this unknown x. So we have plus 4/3 e here plus x is equal to plus 1e. And then to get x on its own, I'm going to subtract the plus 4/3 e from both sides. So I get x is equal to plus 1e on this side minus 4/3 e here. And to write this term with the same denominator as this one, I could write this as plus 3/3e, because that would be the same as plus 1e. And if we had plus 3/3e minus 4/3 e, then we would end up with minus 1/3 e. And that is my final charge on the strange quark. Lastly, question 4 says pions are subatomic particles made up of 2 quarks. There are 3 types of pion. So we have pi plus particles with a charge of plus 1e, pi minus particles with a charge of minus 1e, and pi zero particles with 0 charge. It then says the pi plus particles made up of an up quark and an anti-down quark. Part A says, is a pion classed as a baryon or a meson? Justify your answer. Well, we can say a pion is a meson because it consists of only 2 quarks in a quark-antiquark pair, just like the pi plus particle here is made up of 1 up quark and 1 anti-down quark. Part B says the charge on an up quark is plus 2/3 e. Determine the charge on an anti-down quark. Well, we're going to do something similar to what we did in question 3 here, where we know the overall charge this time, and we want to find the charge on one of the individual quarks. So from the question, we're told the pi plus particle is made up of an up quark and an anti-down quark. So we have u plus d bar, and we can consider the total charge here as plus 2/3 e plus x, where x is the unknown charge on the anti-down quark, is equal to the total charge of the pi plus particle, which is plus 1e, because it's a positive pion. And what we then want to do is find what x is on its own, so we're going to subtract 2/3 e from both sides. So we have x is equal to plus 1e minus 2/3 e, and remember plus 1e is the same as writing plus 3/3e, so if we have plus 3/3e minus 2/3 e, then we end up with plus 1/3 e, and that is our final charge on the anti-down quark. And just a quick check there is to remember that the charge on a down quark is minus a third e, so the antiparticle, the anti-down quark, must have a charge of the same magnitude but opposite sign, so that would be plus a third e, which is what we got here. And lastly, part C says the pi minus particle is the antiparticle of the pi plus particle. State the names of the quarks that make up a pi minus particle. Well, we know that the pi plus particle is made up of an up quark and an anti-down quark, which means the antiparticle of the pi plus will just be made up of the anti-quarks of these ones. So we're going to have an anti-up and a down quark. So we can say that pi minus is made up of the anti-up, the up quark with the bar above it, plus d, which is the anti-quark of the anti-down quark. So therefore we can say it's an anti-up quark and a down quark. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.